The aim of the LISTOR project is to develop a next generation of lithium-ion batteries that will be based on the use of nanomaterials as a positive electrode, as a negative electrode, and as well as electrolytes. The timing, I should say, turned out to be perfect for this research because a huge demand of our society. As you all know, the limitation in fossil fuel is increasingly important. Then people want more energy. The world population is always increasing, so we need to realize what's going on. So definitively we need to better use, I think, the renewable energies. And secondly, if you want to have a less polluted environment, you need to shift to electric transportation. So as you know, in terms of renewable energy, if you look at wind, if you look at sun and so on, these are intermittent. So you need to have a power or at least some storage of energy. Now the same thing, if you want to drive a car, you need to have also power on board, means energy on board. So it turned out that these two large type of application require some high-performing batteries. And hence, the reason why, in order to improve this type of batteries, we move to nanomaterials. So do you recover the powder yet? Or? Yeah. This is the result of the experiment, where in this case what you have these kind of nanoparticles that are dispersed into the reacting media, which is ionic liquid. Then it's going to centrifuge and recover the nanoparticles. These nanoparticles are going to be mixed with carbon and then embedded into an electrode materials that will serve to make an electrode to be mounted in a battery. Revolution in battery design means that in this case you can create electrodes in a different way. But what is more important is that when you have with nanomaterials, you can go at the nanoscale, and in this case you reduce size, you enhance surface area, so you can have a better reactivity. And I should say a faster reactivity. Because within a few exceptions, the real advantage of nanomaterials is to obtain or to design high power batteries. Means battery in which you can really use the electricity as fast as possible. This new battery that we are working on is a type of battery in which we try to meet, I will say, the performance of today batteries with more power rate capabilities. We want to make the batteries that will be safe. We don't know why we need to do a lot of research going to safety, and because you heard so much about working with nanoparticles, sometimes it's dangerous. Here, luckily, we can make the nanoparticles within the batteries. And also, what you want to have a process of making the nanoparticles that it will be relatively cheap. We talk about eco-efficient processes.
So this is the nanomaterials that are embedded into a plastic battery, and then we will add the electrolyte in the glove box.
Okay. Okay, we seal it. Okay, you see, now this stuff is sealed. And the only thing I need to do now is we just need to take some electrolyte. Okay, and I pour electrolyte here. Okay, and now everything is sealed. The nanoparticles and this battery are the black parts, which means is the lithium iron phosphate that is at the nanoparticle stage. Because in the battery, the most important ingredient, of course, is a positive electrode. Because this is from this part that the voltage is coming from and so on.
This battery is made, it's a lithium-ion battery. It's a polymer battery. But what is specific in this battery is that you have some nanomaterial inside. So we are now, here we are in the test room, so we will test now the properties of this battery in terms of capacity and power.
All the components of the battery will be using such type of nanomaterials. And the advantage of using such nanomaterials is for the rate capability, which means that in this case, you can use the energy in a very shorter time, which is really essential for the new type of application, such as hybrid vehicle and so on.